So let's do a little bit of work with StatKey, doing some data analysis. So when we go into our the class website, we've got the StatKey up here, so we'll go to StatKey, and it has all these different tests you can do. We've looked at them a little bit, but we're going to go through a little bit more closely here. So what we'll be typically using, you can look at one quantitative variable. So this is, let's go to, so we've got these data sets up here, different ones that show up in the book. Let's go down to student survey, exercise hours. Okay, I just picked that. And so they display the data three different ways. So a dot plot, which is basically each individual data value has a dot associated with it, so you get a little idea of what the distribution looks like. It's kind of symmetrical down here, a little bit of a tail, so maybe we'd say it's right skewed. Over here we have the summary statistics. So our sample size is 361, mean, standard deviation, and then here's that 5-number summary we've talked about. The minimum first quartile, which is the same as the 25th percentile, the median, middle value, Q3, which is the third quartile or the 75th percentile, and then the maximum. So 25% of the values are less than 5, 50% of the values are less than 8, 75% of the values are less than 12, and 40 is the maximum. Okay, so we have this dot plot. Then we have histograms, and over here, so it's got now, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 buckets, they call them, or categories here, down here for the bars. If you click on a bar to the right, you'll see the lower bound, the upper bound, and the frequency. So between 0 and 4, there were 61 people who exercised between 0 and 4 hours. Here, up to 8 hours, we've got 106 people, etc. So we get some, not only looking at the graph itself and the axes, but down here we can get exact numbers of frequencies if we're interested. So again, we can see this kind of heavy density over here, tail over here to the right. Over here, what we can do is, if we click this button, Set Limits, we can put in a maximum and minimum data value, and then we can choose our number of buckets, which means how many bars are we going to have in the histogram. So there I went to 6. Still looks pretty much the same. A lot over here, this tail to the right. If we went up to 7 buckets, so I've been saying 6 or 7 is a good number. Same thing over here. We've got the right tail. So we've got the dot plot, the histogram, and then we have a box plot. So we've talked about that. We've got, here's Q3 of 5, or Q1 of 5, sorry, Q3, which is 12, the median here at 8, and then down to the minimum, and then values, and then up here, so we said 1.5 times the interquartile range, above or below the IQR, and right here are outliers. So looks like the interquartile range is 12 minus 5 or 7. 1.5 times 7 is 10.5. So 10.5 beyond Q3, which is 12, we'd have 22.5. So any value above 22.5, they're going to be outliers. So here we have 24, 25, 27, 30, 40. Okay, so that's the 3 different ways we can look at that. Let's do this. We go back here, one categorical variable. So we did one day, talked about do people have one true love, and people were surveyed. Do they agree with that, disagree with that? Don't know. So here's a typical categorical variable. We have the bar graph showing the relative sizes of those bars. And then over here we've got the summary statistics and what proportion are in each bar. So 28% agree, 69% disagree, 3% don't know. Okay, so those are relatively straightforward for the categorical variables. Then we've got quantitative and categorical variables. And what this does, we're comparing a quantitative variable based on a category. So here we've got TV viewing by gender. So one graph is for females, one graph is for males, and we can kind of look at the distributions comparatively. So, we might guess, since these values are closer together, maybe females have a lower standard deviation, men have a greater range. Females maybe a little bit skewed to the right, males probably more heavily skewed to the right. And then looking at the summary statistics, we can make some comparisons of the two data sets. So males seem to have a significantly higher average number of hours spent, almost 2.5 hours more. As we can see from the graphs, males higher standard deviation than females. So females more clumped about their mean, males more spread out. And then again, the 5-number summary. Histograms, again, we can set limits. Let's maybe do 6 buckets. Okay. So skewed, both kind of skewed right, seemingly. Maybe we could go 7 buckets by sliding this little bar here. Still looks like males are far more skewed to the right, females more closely lumped together. And then the box plot. Again, we can make some comparisons. Women, lots of outliers, but their outliers are at 12. Male outliers are at 21. So we can see here, the middle 50% are a very small range. So more densely packed to the left. Males skewed right, the median. The first 50% are up to 5. Half of the men watch less than 5 hours. Half of them watch more. So a much wider range for that second 50%. So just some things we can do there. And then something we'll get to later, comparing two categorical variables. So comparing males and females for this one true love gene, or let's look again at the award by gender. Okay, so for, let's see, show legend, males are brown, female blue. So it seems as if for men, they prefer, looks like in terms of numbers, we can look at the raw numbers. Down here we've got proportions, and we can look at row proportion. So for men, 56.5% wanted an Olympic gold, 5.7% wanted Academy Award, about 38% wanted a Nobel. Now we can compare this to the female percentages. Okay, because here it may not, there are more males than females, so just looking at what proportion within an award type may not make sense. Looking across males, so of the males, over half of them would prefer an Olympic medal. Only about 6% want an Academy Award, about 38% want the Nobel. For women, about twice as many are interested in getting an Academy Award, but they're about more want the plurality, or the most common for females is the Nobel, closely followed by the Olympic medal. Okay, so we can just make some comparisons between the genders there, and then later on we'll get to two quantitative variables. So we can look at, let's say, There seems to be some Happy Planet Index, happiness versus life expectancy. So some happiness scale and some life expectancy. This is for certain countries. We can maybe see some relationship. So maybe this looks relatively linear. So happier relates to life expectancy. Who knows? But this will be something for another day. So that's just a basic look at StatKey and how we can use it to analyze data.